Okay, what's up, everyone? Just wanted to do a quick little video. I don't know if it's going to be super quick, but I'm going to try to keep it brief. Quick little video going over some of the practice problems in your Chapter 5, Part 2 homework, where we're calculating frequency, energy, and also wavelength. Just a quick heads up disclaimer. If you hear whining, barking, any tapping in the background, it's my dog. He's out and about, walking around, chewing up his blanket, bothering my cat. You know, the usual. So just a heads up on that. Anyway, let's go on and get started. Problem number 1 reads, a photon has a frequency of 2.68 times 10 to the 6 hertz. Calculate its energy in joules and the wavelength in nanometers. All right, so as with any word problem, you always want to start with the basics, which you're underlining everything that's important and double underlining the question, or in this case, the questions. So we have frequency equals 2.68 times 10 to the 6 hertz. We need to calculate its energy in joules, and then we need to calculate its wavelength in nanometers. Okay. Now, I'm going to list our givens. Okay, so in this case, what are we given? Well, we're given the frequency equals 2.68 times 10 to the 6 hertz. All right, we're looking for the energy equals question mark. We're looking for that in joules. And we're looking for the wavelength, in this case, in nanometers. So a little bit of conversions there. All right. Now, we're going to have two equations that we mostly use. E equals h nu. And then we have lambda equals c over nu. All right. Normally, we have nu equals c over lambda. But we're just going to do the algebra right here just to save space and to save time. Now, the key with these problems is not to try to solve everything at once. Only solve one variable at a time. Don't try to solve the whole equation at once. It's just going to confuse you. Okay? So, in this case, we're going to start with calculating the energy by using E equals h nu. Then we'll swing back and calculate the wavelength using lambda equals c over nu. All right, so I'm going to put a little box around our givens here. So this way we can separate everything out and we have plenty of room to work. Okay, so time to do our work. Okay, so our energy in this case equals h times nu, where h, of course, is Planck's constant, 6.626 times 10 to the negative 34th joules times seconds. Okay? Put this in parentheses just in case we need it later on, which of course we will. Now, we're going to multiply this quantity by the frequency, which in this case is 2.68 times 10 to the 6th hertz. So we know that hertz cancels out because of the identity of hertz, the definition. 1 hertz equals 1 over seconds. So whenever we have hertz and seconds in the same numerator or denominator being multiplied together, they're going to cancel each other out by definition. Okay, so now we're left with joules. That's what we're looking for. So we know that we're on the right track here. So now we plug this into our calculator. Of course, we're going to plug in our parentheses. And this, of course, is going to be multiplication. Or if you're using a TI 83 or 84, which I would suggest using, you won't have to put parentheses in. But always a good idea to put it in just to make sure you're covered. So I'll type that in now. 6.626 times 10 to the negative 34th multiplied by 2.68 times 10 to the 6th. And your final answer that you come up with is 1.775 times 10 to the negative 34th. Oh, sorry. 10 to the negative 27th joules. Now, you'll notice that I have the 5 as a subscript because we need to round to 3 significant figures. So I just put the 5, in this case the 4th significant figure, as a subscript in order to remind myself that I need to round to 3 sig figs. So when we round it, we come up with, this means about 1.78 times 10 to the negative 27th joules. So that's our final answer for energy. All right, so now energy is done. Now we can move on to calculate the nanometers. So let me just clear this stuff out for us. We have nanometers is the wavelength, and we're going to use this equation here. And just to keep everything color-coded, I'm going to do wavelength in blue. So we have wavelength equals c over nu, which means the speed of light, 2.99 times 10 to the 8th meters per second, multiplied by 1 over the frequency, which is 2.68 times 10 to the 6th hertz. Okay. We know that from our definition above that hertz and seconds, when they're multiplied together, that's going to cancel out. So we have hertz, seconds canceled out. Left with meters, but we're not looking for meters. We're looking for nanometers in this case. So we need to make sure that we use a conversion factor. In this case, we need to have nanometers in the numerator. So 10 to the 9th nanometers over 1 meter. Meters cancels out. We're left with nanometers. This is exactly what we're looking for. So now we have to go to the calculator. So we have 2.99 times 10 to the 8th divided by 2.68 times 10 to the 6th multiplied by 10 to the 9th. Okay, so I'm going to pop that in my calculator right now. 2.99 times 10 to the 8th divided by 2.68 times 10 to the 6th multiplied by 10 to the 9th. Okay, so we come up with 1.115 times 10 to the 11th nanometers. We're looking for 3 sig figs here. So therefore our final answer has to be, our final answer has to be 1.12 times 10 to the 11th nanometers equals wavelength. Okay, so now we can see how easy it is in 2 steps here to solve for our energy. and also our wavelength. Okay, so this is the solution to problem number 1. Notice that the key thing that I want you to take away is that I did it step by step. I didn't try to solve everything at once. I just used the variables that was given to me in order to solve the problem at hand. Now let's take a look at number 2. So number 2 reads, calculate the energy in kilojoules and wavelength in micrometers of a photon of light with a frequency of 6.165 times 10 to the 14th hertz. So, as it turns out, it's the exact same step as the previous problem. The difference is now we have a couple little conversion factors that we need to factor in, but it's nothing we can't handle. So, in this case, calculate the energy in kilojoules, so that gets double underlined. Our wavelength in micrometers gets double underlined because we need to calculate both of these. And we have a photon of light with a wavelength of, with a frequency of 6.165 times 10 to the 14th hertz. So, as always, we're going to list our givens. Okay, so we have our frequency, which of course is nu, of 6.165 times 10 to the 14th hertz. Then we have our energy equals question mark in kilojoules. Then, just to keep the color coordination going, we have wavelength equals question mark in micrometers. Okay, so we're always going to list our equations in this case. E equals H nu. And then we have wavelength equals C over nu. Time to do our work. Put a box around my givens. Okay, so our work. We're going to start with our energy. In this case, equals H nu. H is Planck's constant, 6.626 times 10 to the negative 34th joules times seconds. Times that by our frequency, which in this case is 6.165 times 10 to the 14th hertz. As always, when seconds and hertz are multiplied together, they're going to cancel out by definition. So now we're left with joules, which we're not looking for. We're looking for kilojoules. So we need to do a conversion factor. So we're going to multiply this by 1 kilojoule equals 10 to the 3rd joules, or 1,000 joules. Joules now cancels out, so we're left with kilojoules. That's what we're looking for. So now we're good to go. Pop it into our calculator. 6.626 times 10 to the negative 34th. Also, I should say that we need to multiply here. We need to divide here. Okay, so we have 6.626 times 10 to the negative 34th. Multiplied that by 6.165 times 10 to the 14th. And then we're going to divide that entire quantity by 1,000. So, do yourself a favor, okay? Especially if you don't feel too comfortable with the calculators. Okay, so you're going to have 2 sets of parentheses. You're going to have parentheses here and here. Close parentheses here, multiply. Open here, close here, close here. Reason why you want to do it that way is because you're saying that this entire portion here is going to be your numerator. Okay, so you're going to group that whole thing together. And then you're taking that entire quantity and dividing it by 1,000. So the answer that you should come up with is 4.0849 times 10 to the negative 22nd kilojoules. Okay, so of course we need to round to 4 sig figs. So therefore, this answer, the energy is about 4.085 times 10 to the negative 22nd kilojoules. Okay, so that's how you solve for the energy for number 2. Energy is finished. Now let's move on to wavelength. So wavelength, of course, equals C over nu. So therefore, it's going to equal, just going to scroll it up a little bit. We have 2.99 times 10 to the 8th meters per second multiplied by 1 over the frequency, which in this case is 6.165 times 10 to the 14th hertz. We know that hertz and seconds, when they're multiplied in the same plane, they cancel each other out. And we need wavelength in micrometers in this case. Highlighted in green here. Okay, so we need another conversion factor, because down here we have meters, we need micrometers. So we have 10 to the 6th micrometers equals 1 meter. Meters cancels out. So now we're left with straight up calculations that we're used to doing. So 2.99 times 10 to the 8th divided by 6.165 times 10 to the 14th multiplied by 10 to the 6th. So let me punch that into my calculator. Okay, so the answer that you should come up with is 0.48499 micrometers. So this needs to be with the correct sig figs, which is 4 in this case, and also it needs to be in scientific notation. So therefore, wavelength then is about 0.4850 micrometers, which then, put it in scientific notation, is 4.850 times 10 to the negative 1st micrometers. Why is it negative first? We move the decimal point over 1 time to the right, in which case it's going to be more negative, or a negative exponent. So there's our final answer in micrometers and our final answer in kilojoules for number 2. Okay, so hopefully you see that. It seems like it's more work, but when you go one step at a time, it is easy as 1, 2, 3. So here we go. All right, calculate the frequency in gigahertz and the energy in millijoules of blue light that has a wavelength of 400 nanometers. Well, a couple little typos here. This should say of a photon of violet light that has a wavelength of 400 nanometers. Okay, that question makes a lot more sense now. Reason being is because 400 nanometers is in the wavelength of violet light, not blue light. But that's neither here nor there. Well, for now. Okay, anywho, let's go underline what's important. So we need to calculate the frequency in gigahertz and the energy in millijoules of a photon of blue light that has a wavelength of 400 nanometers. So that's single underlined in this case. Okay, so our givens. We have wavelength equals 400 nanometers. Then we have nu equals c over lambda. Well, it does, but we need to have nu in as a question. And we're looking for nu in gigahertz. Okay. And then we're also looking for energy equals h times nu normally, but in this case we're not given nu. So you always want to use the value that's given to you. Okay, even though we could calculate frequency by using this equation, you don't want to use something that you're calculating. Main reason why, you're not 100% sure that it's correct, right? A lot of times, especially as first-year students, you're not sure if your answer is correct until you get, some sort of feedback response from it. So that's the reason why you don't want to use the frequency that you're calculating. That's first. The second reason why, and this is the main reason why, a lot of times you're going to be doing rounding, right? We had to round in the last two problems. So if you're rounding, you don't want to use a rounded answer to calculate it something else. You want to use something that's exact. Okay? So we're not going to use nu in this case, but we will use substitute nu, which is c over lambda. Okay, so that's a substitution that you can always make with no problem. All right, so therefore, energy equals question mark, and we're looking for energy in millijoules. A millijoule on any block. Hey, okay. Anyway. So we're going to box that off. And then we start our work. Now, in this case, I'm going to start with frequency first, just because it was first in our problem. So, our work. We're going to have nu equals c over lambda. You guys should know what to do here. So, we have 2.99 times 10 to the 8th meters per second, multiplied by 1 over 400 nanometers. Automatic red flag should go up. Meters and nanometers are not the same. So we're going to multiply times the conversion factor. So we have 10 to the 9th nanometers over 1 meter. Meters cancels out, nanometers cancels out. That leaves us with hertz. Let's not forget our definition. We have 1 hertz equals 1 over second. So in this case, we have hertz in the numerator. So therefore, we need to have hertz in the denominator to cancel it out. And we need to convert to gigahertz. So 1 gigahertz equals 10 to the 9th hertz. As we know from previous examples, whenever we have seconds and hertz multiplied together in the same numerator or denominator to cancel out, we're left with gigahertz. That's exactly what we're looking for. Now we take it to the calculator. So what do we punch in? Parentheses divided by 400 nanometers multiplied by 10 to the 9th divided by 10 to the 9th. Oh, would you look at that? We have 10 to the 9th in the numerator here, 10 to the 9th in the denominator here. So these two cancel out. So now all we have to do is just plug in 2.99 times 10 to the 8th divided by 400. That comes down to 747,500 gigahertz. This doesn't help us because it's not the correct amount of sig figs, which brings up another point. When we look at 400, okay, it would indicate that there's only 1 sig fig, but well, 1 sig fig because there's no decimal point. But if we add in a decimal point, in this case, now this is going to be 3 significant figures. Okay, so we're going to operate under that principle. Okay, so 400 nanometers exactly. So now we need 3 sig figs, and we need to convert this into scientific notation. So let's do scientific notation first because it's a little bit easier. So we have the decimal place here, move it over 1, 2, 3, 4, 5 spaces to the left. Makes it more positive. Remember, to the left, everything that's positive moves to the left. So we have 7.475 times 10 to the 5th gigahertz. Now we need to round it to 3 sig figs. So therefore it's 7.48 times 10 to the 5th gigahertz equals our frequency. Okay, so that is how we'll calculate our frequency in this case. So let's move on and calculate our energy in millijoules. So remember, we made the switch here. Okay, we substituted in nu for c over lambda. Not a huge deal, but you don't want to use the frequency that you calculated previously, although it would come up with pretty much the same answer. But the reason why I say pretty much is because notice in this step we had to round it. That little squiggly equal sign means about, which indicates the presence of rounding. So let's go back to the source and use the values that was given to us. Okay, so we have E equals h nu, which nu we're going to substitute as c over lambda. So now we have Planck's constant, 6.626 times 10 to the negative 34th joules times seconds, times this by the speed of light, which is 2.99 times 10 to the 8th meters per second. All of this divided by 400 nanometers. Okay, so it looks complex. Don't let it freak you out. Okay, seconds cancels out because we have seconds in the numerator, seconds in the denominator here. Now we have the problem of nanometers and meters, which we need to take care of. So we're going to need a conversion factor. So we're going to have 10 to the 9th nanometers over 1 meter. Now meters is taken care of, nanometers is taken care of. Now we're left with joules, but we need to have millijoules. Okay, so we need another conversion factor. Multiply this by, we have joules in the numerator, so we need joules in the denominator. So 10 to the 3rd millijoules, or 1,000 millijoules, equals 1 joule. Joules now cancels out. We're left with millijoules. Now we can go ahead and solve this problem. Okay, so when we type this in our calculators, you can do it all in one step if you're careful. Okay, so what I would do is I would have, well, I'll show you. Let me type it into my calculator first, and then I'll show you what to do. Okay, so in your calculator, you should have 2 parentheses when you first open it up. Okay, so you're going to have an open parentheses here. I'm going to color coordinate it. Then your second parentheses is for the 6.626 times 10 to the negative 34. Close parentheses puts that in the one quantity. Then you're going to have, I'll make that green. Then you're going to have your speed of light and another set of parentheses. You're going to have your conversion factor for nanometers and another set of parentheses. Then you're going to have your conversion factor for kilojoules and another set of parentheses. Did I say kilojoules? Millijoules. Yeah, millijoules. Another set of parentheses. This last parentheses is to close out the entire thing, divided by 400, and you come up with 4.9529, yada yada yada. Okay, so therefore our answer equals 4.952 times 10 to the negative 16th millijoules. Of course, we need to round that. So now our energy is about 4.95 times 10 to the negative 16th millijoules. Okay, so a little bit longer step. We had to convert nanometers to meters, joules to millijoules, but really the process is all the same. Once you figure out one step, you just take it one step at a time. Don't try to solve the whole problem at once. Only look at it bit by bit. So we have the calculation for energy down here. We made a simple substitution with nu based off what we were given. Okay. And then we solve for energy. And then up top, we had to solve for frequency. You can see the work there. So hopefully this helps you out with solving your problems as well as what's on the worksheet. as well as what's in the study guide packet, of which there's 5 problems that's very similar to this. So if you have any additional questions, please come see me in class, or of course after school on Monday, Wednesdays, and Fridays. All right. Best of luck to you. See you in class.